And now we're going to talk about a very important type of functions, which are exponential functions. So you should have a good idea about what exponential functions look like. So these are functions of the form f of x equals some constant to the x. Okay, and since when x equals 0, no matter what a is, that value is 1, all these functions go through 0, 1. I'm just going to draw two of them. For among all a, the really most important function, exponential function in calculus is e to the x. Okay, and we're going to find out in a second what's so special about e. Let's try to differentiate this function, the general f of x equals a to the x, the general exponential function. So if f of x equals a to the x, then we have f prime of x, as usual, just using the definition, the limit as h goes to 0 of a to the x plus h minus a to the x all over h equals the limit as h goes to 0 of a to the x times a to the h minus a to the x over h, just using the laws of exponents there, equals the limit as h goes to 0. And now I'm going to factor out an a to the x out of this computation so that I have a to the h minus 1 all over h. And I want you to just notice at this moment that this term a to the x has nothing to do with the h. So relative to h, it's constant, so I'm going to pull it out. Okay. Now I want you to sort of notice again that I can rewrite 1 as a to the 0. Just like I said, anything to the 0 is 1. Any non-zero number to the 0 is 1. So that's a to the h minus a to the 0 over h. So notice this is exactly the definition of the derivative at 0. Okay, so we started with a to the x, and we wanted to take its derivative, and we noticed that we ended up with the same function back times the derivative of that function at 0. So it would be interesting if there was such an a value of a such that f prime of 0 were equal to 1, because for that value of a, it would mean that the derivative of the function is itself. And that value of a that satisfies f prime of 0 equals 1 is the number e, which equals 2.71, etc. So it is just a number, but it's a very special number that has the property that when you differentiate e to the x, you get it back. Okay? In fact, we can define e to be this exact number that gives us the property that e to the x is its own derivative. But how about if a doesn't equal e? then what is this value, f prime at 0? Where we're going to show later that that is actually just natural log of a. Okay, and of course, if you put e inside here, the natural log of e is just 1. Now let's continue on to derive the derivative of natural log. Now we're going to derive the derivative of natural log. But first, let's review the chain rule. Recall the chain rule says that the derivative of f composed with g is the derivative of f evaluated at g times the derivative of g with respect to x. Okay. Now suppose f and g are inverses. For example, let f equal e to the x and g equal ln x. Then what? Well, then by definition of inverse, x equals f composed with g. Now I'm going to take the derivative of both sides. What's the derivative of x? 1 equals the derivative of f composed with g is f prime of g times g prime. Now if f is e to the x, we know its derivative is just itself, right? But we're evaluating it at g, so it's e to the ln x, that's this part, times the derivative of natural log, which is what g prime is. So another way to write this, I'm going to write it like this, ln of x prime. This prime just means the derivative of this function. So what do we have? This is just x. This is what we want to know. So if we want this, we just divide 1 by x. So therefore, 1 over x is the derivative of natural log of x. Great, we've just derived the derivative of natural log using the chain rule. We're just going to take it one step further and ask, then, since we know the derivative of ln x, what's the derivative of the inverse of a to the x, which is log base a to the x? Well, remember the change of basis rule. This log of x with base a is just natural log of x divided by natural log of a. Natural log of a is just a constant with respect to x, so we can pull that out. And we know the natural log of a. The derivative of the natural log of x is 1 over x. So there we have it. We now have the derivative of natural log and the derivative of log with an arbitrary base a.